So, okay, number 7 and 8 on the worksheet. Okay, so it says instead of sand, so in the previous part we had sand from D to E. So instead of sand, let there be a spring mounted as shown over here. So you know what? Here's what I'm going to do. I'm going to grab, watch this. I'm going to grab this spring, pick it up. What they're saying is point D, look at that. Bam. So now instead of there being sand there, it's a spring. Okay, so we'll erase this. So what's the question? So 7, when the van arrives at point D, it begins to compress the spring. You know what, guys? I want to do part 8 first. I think 8, it'll be a little easier to do that. Let's do number 8. What was the maximum compression of the spring? So the van, before the van hits the spring, what type of energy does it have? Well, look, it depends where your 0 point is. Previously, we had the 0 point down here. If we keep the 0 point down here, what energy does the van have up there? If the 0 point is down here, what type of energy would the van have? Potential
of gravity
plus
kinetic.
Plus kinetic, if the 0 point's there. But you know what I would do? I would just move the 0 point. For question 8 here, for 7 and 8, I would just put the 0 point up here, right? If we put the 0 point up here, then what type of energy do we not have? Potential. There'd be no potential, and we'd only have kinetic. Well, how much kinetic do we have before the van hits the spring? How much kinetic does it have? Can we figure that out? Yeah, well look, mechanical energy, what's the mechanical energy at every single point on this problem? 1 joule. The mechanical energy was 1 joule. So when the 0 point was down here, the van up here, the mechanical energy was equal to kinetic plus potential. This potential, we can find out what it is, right? Potential energy is mgh. So when you plug into that, the potential energy comes out to be 0.8 joules up there, right? So if the mechanical energy is 1, what must the kinetic be? Nathan?
0.2 joules.
0.2, right? So long story short, before the van hits the spring, it has 0.2 joules of kinetic energy. Okay? Before the van hits the spring, it has 0.2 joules of kinetic. Well, we're not done yet. Now I got to solve number 8. Okay, so here's the van. It's coming in, and it has a kinetic energy. So we're going to have the 0 point be up here, right? This is going to be our 0 point for 7 and 8. So the kinetic energy is equal to 0.2 joules before it hits the spring. So then the van hits the spring goes smush, 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 it smushes back. For a split second, everything stops, right? For a split second, everything stops. And what will the energy be in?
Potential energy of spring.
It'll be potential of spring. Does that make sense? So it's like this. Let me draw it bigger. So here's this wall. Here's this wall like this. Here's the spring. There's the spring. The van hits the spring, right? The van hits the spring, and the spring goes smush, 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 smush. It smushes back. For a split second, the velocity is what? 0, which means no kinetic. So what type of energy do we have when the spring is fully smushed?
Potential spring.
Potential of spring. So here's what has to be true. The kinetic energy before the van hits the spring, the kinetic energy before must equal the potential energy in the spring, right? All we're saying here is mechanical energy initial equals mechanical energy final. What type of mechanical energy do we have before the van hits the spring? We have kinetic. And then what do we have when the van is all the way smushed into the spring? Potential. All right, what was the kinetic before? 0.2. And then that equals 1/2. The equation for potential of spring is 1/2 kx squared. And now we can solve for x. 2 times 0.2 joules over k, which is 10 Newton per meter. So this gives an x equal to 0.2. That makes sense? Basically, long story short, before the van hits the spring, it has kinetic. When the van is fully smushed into the spring, it has potential, and then you set those equal to each other and solve for x, where x is how far the spring got compressed. Okay, now let's do number 7. Everybody got this copied? Or you can watch it at home. Oh, you know what? I didn't save this. Hold on, I gotta pause the video. Okay. All right, so number 7. When the van arrives at point D, it begins to compress the spring. At the instant the spring is compressed 0.1 meters. So look, is the spring fully compressed at 0.1 meters? Here's the spring. So look, how far did the spring get compressed? It got compressed 0.2. So what we're doing is we're going to focus on the spring when it's halfway compressed. So when the spring is right here, when this x equals 0.1. So is the van still moving? Because it's not going to stop until it gets over to here, right? So we're focusing on the situation when the spring has been compressed 0.1 meters. Okay, what type of energy do we have right before the van hits? Right before the van hits, what type of energy do we have?
Kinetic plus potential.
Well, I would keep the 0 point up here.
Oh.
Have this be the 0 point up here. So it's only kinetic. All right, when the spring is partially compressed, what type of energy do we have?
Potential spring.
We have kinetic, because the van's still moving, plus we have potential of spring, right? Why do we have potential of spring? Because it's partially compressed, right? If the spring is being smushed a little bit, there's energy stored in it. Okay, what has to be true? These two circles have to be equal, right? That's conservation of energy. All we're saying here is mechanical energy initial equals mechanical energy final. And remember, the only time you can say that is when gravity or spring are the only forces affecting the motion. What's the only force affecting the motion in this situation? The spring. So we can use this. Okay, what's the mechanical energy before the collision? Kinetic. What type of energy do we have when the spring is partially compressed? Kinetic plus potential of spring. All right, what was kinetic initial? 0.2. Kinetic final is what we're looking for, right? We're looking for kinetic final, so we'll just put kinetic final. And then for potential of spring, that's 1/2 kx squared. All right, so now, do we know what k is? Yeah. Do we know what x is? Yeah. So basically, we have, in this equation, we know everything except kinetic final, right? So you can solve for kinetic final. So kinetic final is going to be 0.2 minus 1/2 10.1 squared. All right, just plug in the values, and this comes out as 0.15 joules,
So,
which is the answer right here. Yo.
so how's K 10 newtons per meter?
That's the unit for spring constant. It's right here. This spring down here had a spring constant of 200 newtons per meter. But in this problem, they tell us that this spring up here, they say it right here, has a spring constant of 10.
All right, I see that.
Okay. So then for the last question, they want the velocity when the spring is compressed 0.1 meters. What would be the velocity of the van right there? How do we get that? Well, we have the kinetic, right? We got the kinetic. What is kinetic equal to?
1/2 mv squared.
1/2 mv squared. So V is going to be square root 2 times kinetic energy over m. So that's going to be 2 times 0.15 joules over, what's the mass? 0.1. So this comes out with a velocity of square root of 3, which is 1.7. But here, the worksheet just says square root of 3.
Okay.